Welcome everyone. We'll try to make it quick so that you can get to lunch in time. So Vince from GraphAware and I, Michael from Neo Technology, want to talk about Spring Data Neo4j 4. Just a quick show of hands. Who of you has used Spring Data Neo4j in one way or another? Okay, cool. That's great. So you're aware of some of the problems that we have when connecting to Neo4j server, but we're going to fix that, and that's why we started to write a new variant for Spring Data Neo4j from scratch, and that's what we're going to talk about today. Yeah. So I don't have to do the intro why Neo4j at all, because you're at Graph Connect, so I can easily skip that. But just the message is relationships matter, right? And they matter everywhere. Okay, Spring Data. So you probably know that the Spring Data project is the Spring Source project that gives Spring developers access to NoSQL databases in a convenient way with consistent APIs. And Spring Data Neo4j is one of the core projects there. And as you can see, there are a number of different databases, and it's in active development. And there are a number of people at Pivotal that work on it, and also outside of Pivotal. For Spring Data Neo4j, some quick history. It started actually as an fun project of Emil and Rod Johnson, who wanted to get back to coding, and so started with version 0. Then they handed it over to me and us, and so we added things like object graph mapping, working on embedded Neo4j, Neo4j template. With Neo4j 2, we added label support, and so on. But as it had a history on running on embedded Neo4j, because when we started, there was no server, there was no Cypher, there was just Neo4j embedded and the Java API. So much of the internals of Spring Data Neo4j were built around this. And that's why running Spring Data Neo4j against server was never as fast as I wanted it to be, and I never actually had the time to focus on making it fast. So with SDN 3, especially at 3.3, I invested some time to make it faster with server, but I know, or I knew at the same time that we were planning to start a new initiative, meaning rewriting Spring Data Neo4j from scratch. So Spring Data Neo4j 4 is new and shiny from scratch with lessons learned, what we wanted to make better, focus on Neo4j server, built on Cypher, built on the Cypher transactional endpoint, and also based on a plain Java object graph mapper, which you can also use independently of Spring. And Vince will talk about the features.
Yeah, so Spring Data 4 was a complete rewrite because we noticed that over the development of SDN 1, 2, and 3, we had moved increasingly into being really tied into the embedded mode. And so we decided we needed to do something completely different because in order to support server, it would have meant too many changes to the existing code base. So we decided we'd rewrite from scratch. And a transport protocol, as you know, is Cypher. There's a new binary protocol coming soon. So we had to do everything using Cypher. And because of that, we really had to focus on performance. We were expecting, obviously, we needed to reduce latency. We needed to make sure we were writing efficient Cypher, and so on and so forth. The other thing we wanted to do was to make sure that we could decouple the OGM itself, an object graph mapping layer, from Spring, so that you could use it. If you're not a Spring shop, you can use the mapping layer independently of any of the Spring wrappers. And we also wanted to make sure we supported authentication. 2.2 was already out, and SDN 3 is coming up with support for 2.2 very shortly, I think. Yeah, but we wanted to be ready for 2.2 as well, so we could hit the ground running with that. So we've done a number of different things in order to really improve performance for SDN 4, given that we now have to go over the wire. The first of those is we've got what we call vampire metadata scanning. We're not using reflection to load all the metadata about your domain classes. Instead, we load the class objects directly from memory. So it's much, much faster. And although it sounds like it's something you only do once, so maybe it's not that important. In fact, if you think about a larger kind of infrastructure where maybe you're running lots of different microservices and Neo4j is installed in those microservices, and one of those servers goes down, you want to be able to start up super fast. You don't want to be spending lots and lots of time re-scanning all your domain model again. So the other thing we've got is we've actually written the Cypher compiler internally in such a way that we build up operations that we want to do rather than sending Cypher directly straight away. So only at the point that you want to save something, we know all the different operations you want to do, so we can actually tune the Cypher that we create specifically for the kind of operations you need. So you may be doing something like in one transaction or part of the transaction you've made a change, and another one you've actually deleted the object that you were changing. So we would know not to make the change and the deletion together, for example. We've also got something called smart object mapping. Smart object mapping really is a means of ensuring that we send only the Cypher that will make a change to the database that needs to be made. We don't want to send out lots and lots of different things down to the Cypher, down to Neo4j over Cypher, where you already have got the data in exactly the same format. And the reason why that's important is because we actually have variable depth persistence. What that means is your data often, if you're looking at something like, I want to say I'm interested in a piece of information about a customer, that's my focus. But actually very often you're interested not just in the customer themselves, but the immediate locality of things around that customer. And previously you'd have to get the customer, you'd have to get the relationship, you'd have to get all those things around that. By default now, what we do is we load the object of interest and then everything else around it one hop away from the graph, by default. You can change that persistence level behavior, but it means that you can get most of your related information in one hit from Cypher. It's much, much quicker to do it that way. Of course, sometimes you don't want to do that. Instead, you might just want a list of customer names or something like that, in which case you don't want to collect all the related information, sort of the master detail kind of idea. And by default, so that's on loading, but you can change your load depth however much you like. So if you say, if your particular graph is extremely deep, but not very wide, then you might think, well, okay, I don't need to worry about the default depth, which is depth 1. I want to go depth 5, depth 6 with my particular model. And you can tune it for different queries as well. So your particular query might want to have a deep fetch through the graph. Another one might be fairly shallow. And this is all tunable through variable depth persistence. But in order to do that, the smart object mapping needs to know what you've done, what you've fetched, what you haven't fetched. And we can detect changes to properties for nodes, properties for relationships. We can detect deleted relationships and so on. And the whole idea of this is to make the actual Cypher that goes sent across the wire as efficient as possible and as fast as possible. So the other thing is, one other thing is annotations are optional. If you have, you're used to Spring SDN annotations. Who uses SDN currently? Any hands, show of hands? Most people, okay. So the annotations are optional, so that if you have a model which is very simple, you don't need relationship entities, for example. You must have an annotation if you want to use a relationship entity. But if you don't have a very simple model, you don't need to use the annotations. The other thing we've got is mapping contexts, which are tied to session lifetimes. And the session here is the Neo4j session. It's the conversation you're having with the database. So you can say, I want to tie it to an application level, so maybe I'm running some process that runs from the command line on a batch process every day, and I'm doing this, and my application needs to be up and running all the time. I connect my Neo4j session once. And it has an effect on the mapping context, because the mapping context is tied to that session lifetime. Or you can have an HTTP session lifetime connection, or you can have a request-based one. So you've got lots of different flexibility about the lifetime of your Neo4j session that you want to use. On the Spring side of things, all that is usable, of course, directly from Java, basically. You don't need any of the Spring wrappers at all. You can just use the object graph mapper. But Spring gives you a lot more. Gives you templated methods, transactions, repositories, the queries, and, of course, exception translation as well. So we wanted to keep them separate because we know that some people don't use Spring, and we wanted to make this available to as many people who use Neo4j as possible. So where are we now on progress? Well, we started in September. We've been at it for about 6 months now, a bit over 6 months. Milestone 1 has been released already. Milestone 2, we're hoping to be out by the end of this month, and hopefully to GA full release before the end of the summer. That's what we're hoping. It depends a lot on integrating with the Spring release train as well. Okay, so we're going to show you an example application. Now, unfortunately, I said a bit earlier, these slides are from a slightly different presentation we did. So the conference application here won't apply to this particular conference, but the principles will be the same. Okay. So we want to talk about the domain model? Yeah.
So being at a conference, you know, we have the typical things like We have a session like this that you're in. You have speakers which present the session, but speakers are also like attendees registered for the conference. Conference has tracks or rooms. We have time slots, and sessions have topics. Typical graph domain model, nothing special, right? And what I want to quickly to show you is getting the data into Neo4j is something you can do with or without Spring Data Neo4j. And so in this example, we had for Spring I/O last week data in JSON, and we just used Cypher to deconstruct the JSON, create the data for Neo4j. So this is the JSON. We can use Cypher's, for instance, dot notation and unwind syntax and array indexing to access certain parts of the JSON. So we can just create speaker sessions and connections between those just by deconstructing the data. But we can do the same for CSV. So for instance, for Graph Connect, actually we got CSV files from Rick's blog post. And so we can also just use load CSV to create the data model, right? And creating the data model is something like that. And I just pour in either, in this case, JSON or a CSV file, and then I can create a whole data model in one go without having to do multiple steps or something like that. And at the end of this, which is just a bunch of create and merge statements for nodes and relationships, we get a Groovy script that runs this, getting the JSON, parsing it, and sending it to Neo4j. It's kind of all the code you need. You get a graph model like that, right? So the typical things that I already mentioned, sessions, speakers, rooms, tracks, time slots, and so on, and topics. The idea here is to show you, even if your data model or your data in a graph comes from a different application or from a different load script, you can use Spring Data Neo4j 4 directly on this data model. So you don't have to augment or change or adapt this data model to use a Spring application with it. You can also decide, I just want to use the Spring application for a part of the data model, so for a certain aspect of it, and expose it either directly as an application or as an REST interface as a microservice, for instance. So that's kind of, we got the data in a graph, and now the next step would be looking at the Spring Data code, Spring Data Neo4j 4 code that's needed to build the application.
So we decided we'd build a little application around about Spring Boot, such an easy thing to do. And it's very, very simple. Straightforward Spring Boot application. We've basically got ordinary REST controllers, services, repositories, and just persisting some entity classes. So we really just want to show you very briefly how you would set up your domain classes to work with Neo4j and Spring Data. The first thing we're going to show you is the Spring Boot application configuration. You'll notice at the top there's now a single annotation Spring Boot application that stops you having to do all these three things there. The other thing, as a general good point of a good practice, is that if you're going to use multiple persistence configs or different configs like this, import your persistence config. So that's what we're doing here. Keep your Spring Boot config separate, and we're going to have a look at the persistence config in a second, which is this one here. I just want to show you a few things. First of all, we enable the Neo4j repositories in exactly the same way as you would expect to do, with your base packages pointing to your repository directory or path. Enable transaction management, as you expect. The interesting stuff, the new stuff, is Neo4j server, get session factory, and get session. So I'm just quickly going to run through those things with you. This is a standard config you'd use. Here we're using a remote server. So here we just define the URL for the server we want to use. It could be localhost. It could be on any machine, obviously. It could be an HA proxy front end as well. The other thing is now we're doing our session factory. This is, if you're familiar with Hibernate, it's built on very similar ideas. You have a session factory, and it needs to understand your domain model. And so when we start the session factory up, that's when the magic class path scanning happens, and we load all your class info very, very quickly. And the final thing is, for each session factory, you have a session factory, and you're going to get a session every time you need it. So this is how you'd normally scope it. This one is, because we're in a Spring Boot application, we're a web app, we have scoped our session bean to the HTTP session. Okay, so it's very simple. Just three things that need to be done, basically. Right, so just a quick reminder of the domain model before we move on. This is conferences, tracks, time slots, sessions, etc. And because it's a simple CRUD application, all I've done here is I've just basically created an abstract entity class, which is going to have the core things that every entity is going to have on it, an ID and a name. So the first thing to notice is the graph ID. You don't need it if you're using a long as your ID and it's called ID. You don't need that annotation, but it's there just to remind you. The other thing to mention very briefly is that we're using the JSON generator class for passing information across in JSON. It gives you the ability to write effectively self-referential graphs in JSON. Normally the references are maintained for you. So it's very good, very simple. And the only thing you need to do is just tell the generator what your JSON property is it needs to reference, ID in this case. So on to the real stuff. This is the session class, the session as in a talk. Node entity is we have to have node entity and relationship entity. So we can't just use the JP entity annotation. We have to have separate ones. In this particular case, because the class is called session, you don't need to use the annotation node entity there. It will automatically do it for you. It's just there for reminding. The relationship is very similar. All the relationships are there: type at, time slot, in track, presents. And we have a different one on the set of speakers, the presenters, where we best specify that the direction in the graph is incoming. So it's all pretty straightforward if you're used to this. I'm going to flick through the others. I don't think there's very much more on these ones. They're doing exactly the same thing. So just to show you how it works, 2 more incoming directions there. And then on the repositories, we can use query methods and so on. In this case, we're looking for a topic by popularity, finding the number of topics and the number of hits there are on those things. So we're going to return that as a query. So you can add ad hoc queries in exactly the same way as you're used to doing now. Session repository has a similar thing. We want to find similar sessions to the one we're looking at now. So I know we're a bit pressed for time, so we're going to quickly go through these. Just in terms of implementation, this really is, the only point about this is to show you is we talked earlier about the depth you can load and persist to, and here we've got depth list of 0 for things that are lists, and depth list 1 for our entities, where we're fetching a list of things, then we want to fetch the detail for those things. We can specify different depths, and that's just to show you how that would work there. You notice the find one method on the get repository there takes an optional depth method. You don't have to use it. If you don't put it in, it'll default to the default, which is depth 1 for loading and everything for persisting. So if in terms of just persisting, I should have told you earlier, when you save any entity in your domain model, we will persist everything by default that we can reach from it. You don't have to save the person and then the related objects and so on. You just do one thing you need to do to save something. So any point in your graph that's connected, you can save from. So that's another important thing to say. You can save if you've got a collection of movies and actors and they're connected together. You can save a movie and it will save the related actors. Save actor, it will save the related movies for you. So you don't have to save them all separately. If we can connect you, we will save you. Okay, so this is a standard service method here. The reason we were giving this talk last time, people weren't particularly familiar with all the stuff, but you guys probably know most of this now. So we just auto-wire our repository into our service in the standard way. And then we have our API mapping for our standard controllers. In this case, we have an abstract controller that takes a particular type. Anything? No, that's all there. Okay. So yeah, so our application, which we are going to be able to show you actually, is based on JHipster from the front end, similar track speaker, and five different files. You can download this application from the internet. You can have a look at it. We're going to show you the list of things later on that you can have a look at and see how we've done it if you're interested in having a look at that as well. Okay, let's see if we can get this up. See if we can get this here. This one here, there we go. And this one? I'll just do this one here. We're going to get there? Yep. It's not gone full screen, but never mind. Okay. So here, very, very briefly now, I'm going to have to drive this through the mouse because my trackpad's failing. But we can see our talks. We could see our talks. We can't see our talks. No. So unfortunately, because of the glitch of the demo earlier on, we haven't got any data to show you. So all I'm afraid you're able to see is a cute picture of a baby reading a book about graph theory. Sorry about that. We had a bit of a last-minute panic on this. So yeah, I can't really show you the demo right now.
Do you have the screenshots on me?
I have no screenshots for this one, no. So
on the other one?
No, not here.
Okay.
Yeah, that's it really. Okay.
So the application is on the GitHub repository on the SDN4 conference. So you can just download it, start it, and then you can explore it yourself. Something that we want to... actually, we have screenshots.
No, we do have screenshots, yeah.
So the screenshots show you kind of a detailed screen of a session, which not only pulls in the session attributes like name and so on, but also related attributes like, in this case, speakers, topics, track, and time slot. So that's kind of defined, that's one thing. And then you also have mapping of the repository methods like popular topics directly on an Angular page as well. As we're closing down, so as Vince said, milestone 1 is out, so you can test it. And we really would like to have more feedback on that. So if you find the time, we would be really appreciating you trying it out and giving us feedback on if that's what you expect, both in terms of performance as well in terms of migration guide, documentation, and examples and functionality. And yeah, we're looking forward for feedback and hope to get it developed and finished really quickly so that we can get it out and everyone can use it.
Yeah, so milestone 1 is already out and you can use it. It's got most of the features you'll probably want. We're still developing other features. Go to Jira, have a look at what we're doing on the Jira at the moment and see if there's anything else you'd like in terms of features. Put a request in for them there as well. We really do value your feedback on where we're going and how far we've got with it, particularly what you like, what you're finding difficulty with as well. We'll be starting a new set of blog posts on the GraphAware blog site as well about using SDN. So you'll be able to find out if you're not an SDN user, you've not used Spring Data before, it'll take you right through from sort of first principles. We're going to sort of do a kind of tutorial over several sessions, several blogs. So look out for that as well. Our team are here, the GraphAware team are all here. So we can all be contacted as well. If you have any problems, the first place to ask is probably, if you can't find anything on our blogs, go to Stack Overflow first. You'll find a lot of information there. Ask a question on Stack Overflow. Failing that, or even as well, email one of us on the team as well. So Vince at GraphAware, there's Luan, and there's Adam as well. I had a slide with all our names on it, unfortunately, but yeah, so Vince at GraphAware, Adam at GraphAware, and Luan at GraphAware. We're the SDN team, and we're here to help you. So thank you very much.